Okay, fourth graders, today is November 13th, and we are continuing on with Module 3, Lesson 15. And as your learning goal says, today we're going to learn how to use arrays and area models to help us solve division problems that have remainders. Okay, we're going to talk a little bit about this later in the lesson, but I want us to pay attention to the words array and the word area models, because those are the two methods we're going to be using today, the two strategies. And we already know some stuff about area models and arrays actually, but we're going to see how those relate to division today. As you know, since I'm not here today to teach a lesson and you're learning through the video, make sure that you pause frequently so that you can take good math notes and follow along well. You should have already gone over the problem of the day with your sub, but if not, pause the video right now to make sure you write down what the question's asking, the important information, and then show how you know. Then you can unpause to check your answer against mine. Because we know that 4 photos can fit on one page, we can make a chart like this to show how many pages there would be and how many photos there would be on that page. For example, if she had 8 pages, she could use 32 photos. Now, because I know she has 38 photos altogether, 9 pages would allow for 36 photos, but that's not enough. So she has to go on to the 10th page, which would fit a maximum of 40 photos, but she only has 38, and that's okay. Maybe she has space for 2 extra photos. So the answer is 10 pages of photos. Okay, when we're talking about a division problem like this one right here, 10 divided by 2, we have to know the different parts of a division problem. We know that the first number is called the whole, because that's all of it. That's the whole amount that we have to start out with. The second number, the one after the division sign, is called the divisor. The divisor tells us how many groups or the size of the group that we're trying to divide everything into. The answer to a division problem is called the quotient. So the missing part right now, the answer would be a quotient. So we're always trying to find the quotient when we're trying to find the answer of a division problem. So in this case, the whole is 10. The divisor is 2. It tells us that we start out with 10 things and we're dividing it into 2 groups. So if I know that I want to divide it into 2 groups, I can show this using an array by arranging 10 things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 items all together and they're in 2 groups. Here's one group and here's another group. 2 groups all together. The quotient is how many are inside one group. So let's see how many are inside one group. 1, 2, 3, 4, 5. So the quotient is 5 because there are 5 items in the group. This checks out with the math facts. We know that 10 divided by 2 is 5 because 5 times 2 is 10. As a reminder, multiplication and division are inverse operations. So that's how I can show it using an array. Remember, an array is a symbol or an object grouped into lines and columns. You can see here that we have rows and columns, so therefore it's an array. Now using an area model, I want the area to be the whole. That means I need my area to be 10, and I need one of the dimensions to be 2. So if I use 2 here, and I want there to be 10, that means I have to have 5 across. 1, 2, 3, 4, 5. And so there, oops, let me make the bottom blue to be consistent. So here I have a rectangle that is 2 by 5, which uses up a total of 10 squares. And so this is how you can use an area model to show that 10 squares divided into 2 rows. You'll see there's one row here and one row here. It takes 5 in a row to make 2 rows of 10. Okay, so thinking of an area model, it's kind of just like an array, but here is the area model. Don't forget to pause to take some math notes. Make sure you've drawn the array and the area model into your notebook group. Let's try another example here. Now we have 11 divided by 2. So using an array, we know that the whole is 11. We're going to have 11 objects. The divisor is 2 that we need to sort into 2 groups. And the quotient is going to be how many. Okay, so we're going to start off with 11 objects, and I need them to be in 2 groups. So I'm going to put them in 2 lines so that I have 2 groups, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've now drawn 10, but I have 11. So I have one extra. Now that one extra can't be put into one of the groups because it can't be divided into two. I only have one. So here's one group, here's another group, and here's an extra. We call the extra what is remaining. We call it the remainder, right? So in order to find the quotient, we can see, okay, how many are in each group? 1, 2, 3, 4, and 5. So again, the quotient is 5, but this time we have one left over. We call that a remainder. And we write that using an R, remainder, 1. Now, let's see how we can show this equation using an array, or sorry, using an area model this time. I know from last time that if I had 2 times 5, that would equal 10. Is there a way I can make just one rectangle to show 11 boxes? No. So I have to show that there's one extra box on the side like that. So again, this array is 2 by 5, which equals 10. And then I have to add one extra little box there on the side. Again, pause it to take some good math notes. Let's try one more example. Here's the whole. We have 38 objects. We're trying to arrange them into 4 groups. I'm going to end up with a quotient, right? The answer is the quotient is how many are in one group. So because I know I want to divide it into 4 groups, 1, 2, 3, 4, or sorry, I'm gonna split it up like this. So you can see that I have 4 groups there. 1, 2, 3, sorry. Now I have 4 groups, right? So I'm going to start to divide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I need to keep going until I get to 38. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. Now I got to 38, but I don't have enough to share an equal amount into these 2 last groups. So what I have to do is I have to take away this one and this one. Now all of my groups have the same amount, but I have 2 extra over here that can't be shared, right? So that's the remainder. I know that I have 2 remaining, so I'm going to write remainder 2. In order to see what my quotient is, I'm going to see how many are in each group. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my answer is 9, remainder 2. The remainder is also part of the answer. Don't forget that. The quotient is 9, the remainder is 2, but the whole thing is the answer. Now, based on our last example, when we had a remainder of 1, could we add that 1 square to our area model, or did it have to be a separate rectangle? It had to be separate. It was something extra on the side. So same thing here. In order to show this using an area model, I can get 36 squares by doing 9 times 4, right? 1, 2, 3, 4. Based on our math facts, we know 1, 2, 3, 4, 5, 6, 7, 8, 9. We know that this is 36 squares. 4 times 9 equals 36. But we want to end up with 38, right? So we have to add 2 extra on the side plus 2. And we write that using remainder 2. Okay, so you can see all together there's 38. Could I make one rectangle that has only 38 squares, but also has 4 as one of its measurements? No, the answer is no, and that's why we have a remainder. Today, to help you practice this, please do the following problems in your Lesson 15 problem set, and then move on to your exit ticket. Once you're done with your exit ticket, please do Zern, Lesson 15, and then the rest of your practice problems for extra practice. Thanks.